All right, well, we wait to see if anybody else comes in. Was there anything you're hitting a wall on? Any pain points? How's your science going?
What's the question? How is everything going?
Yeah, how are you doing so far?
The homework this time is really hard. Um, I'm still on the first task trying to figure that out. But I think I'm gonna ask AI as like a mentor and figure that out.
Exactly. That's a good way to do it. Especially if you're using, you know, Claude or ChatGPT or any of those, just tell it to not to do it for you, but to work with it step by step with you. Like you can even give it a role and be like, you are my tutor or something, my mentor, my
Yeah,
tutor.
yeah, that's what I'm
Yeah,
doing because I want to
yeah,
understand myself how things work. And
there you go.
decorators and closures, these two things I don't understand at all. I mean, I know the general, like what decorator does and the code, the structure of the decorator, but in the task particular first task, I don't know the role of decorator. But yeah, as you said, there's a tutor me by Agahan, I think. Khan Academy. They have a tutor me AI, so I'm using that
Hmm.
as my tutor to figure it out.
Good, good. Yeah, and if like I say every week, if you have any questions, just shoot me a Slack message. I'll try to help you when I can.
Thank you. Yes, I will.
No problem. All right, welcome, Anna. Let's go ahead and give it about 2 more minutes, see if anybody else wants to trickle in. How about you, Anna? You got any things you're struggling on? How are the decorators for you?
Okay, I see. She says that she can turn her mic on.
Oh, yep.
Uh,
I see your
mm.
chat. Yep, I see your chat right here. That's fine.
By the way,
Not
I
a
like your
problem.
web page. How did you do that so quick? Do you build yourself or?
This one right here? Yeah. As you get better with the fundamentals, you're going to be able to give what's called like design patterns to your AI helpers. So the important thing about learning these fundamentals now is because instead of like what all these vibe coders are doing and using just natural language, just be like, oh, I want this page. Instead, I wrote out, you know, a list of parameters, decorators, and assignments of what I wanted covered. I set a limit on how advanced I wanted it to be because I knew that you guys are still kind of in the novice area, so I didn't want to jump into higher level like recursion and stuff like that and confuse you guys with the lesson plan. Yeah, so we will
Right,
definitely cover decorators today. And
that's
so
great.
as you get more knowledge in how you want to word your prompts and you get more technical with it, you're going to be able to use your AI tools as sort of an intern. They're never going to replace humans, but they can do a lot of the repetitive, redundant tasks for you, like writing all the boilerplate for it for an HTML lesson plan. And then you go back in and handle the conceptualization and making those intuitive leaps that only a human being can make. And so that's the difference between agentic programming, which is what we're teaching you, and this vibe coding phenomenon that's out right now. Like I know you see like the base 44s and the lovables and the spaghetti slop and whatever the other one is. Like
I
so
have a question. How did
sure.
you build your own AI helper? Is it like a personal kind of agent, or you using like those like tools, Copilot and stuff, or you created your own helper for yourself?
Yeah, so as we get farther down in the course, you're going to see things like API calls to LLMs and what's called MCP servers, which are model context. And so these tools will allow you to go through the API calls of different servers. So I use Anthropic, which is Claude, and then I use Gemini, and Gemma, I think, is the back end of it, because it's the same thing that powers Gemini 2.5. And then I also use Perplexity. So because of my paid subscriptions, I can use API calls. I set rate limits, and then I set kind of a cascading, it's like a waterfall of like loading. So if it's a very simple question, just use the free model. If it's something that you have to do a lot of research for, then you start using the token utilization and going to get a more, accurate answer. And so you guys will get into that very soon, actually, because you're going to start looking at different vectors and how this all ties together, just like we did last week with the tank game. All this object-oriented programming, the list comprehensions, the decorators, the closures, that is going to be the fundamental building blocks of how you tackle these more advanced concepts, because really these advanced concepts are nothing but all of these little concepts built together. Does that make sense to y'all?
Yeah, yeah, I see. Thank you for answering the question. Now it all makes sense. It's
Of
actually
course,
exciting as we learn
it is.
and we're gonna dive into.
Yeah, and it's like the Wild West. So, like what I do, they rename it like every couple of months. Like what I was called an applied associate engineer, AI solutions engineer. I've been called a agentic programmer, a natural language I don't know. They can't the terms change all the time. You're in a curriculum that is trying to keep up with a technology that changes every day. So if you like learning new things, you're in the right spot because something new comes out every week. It's really fun. So now that we nerded out for a second, let's see if I can answer some of your questions about object-oriented programming. So today I'm going to use the analogies of like video games, since we did video games last week, and make it a little bit more fun. Maybe it'll help you conceptualize these difficult terms. So today we're going to cover object-oriented programming, which is where you build your own data types. We're going to create a couple custom objects. And the example I'm going to use is building character classes in a role-playing game. Decorators. Again, we're going to use for power-ups for functions. So we wrap the functions with extra abilities, changing the core of the function. So I can see where this is something that you guys are kind of hanging on because it's tricky at first. But when I break it down for you, you guys are going to get that aha moment. And then if we have to take the rest of the class on the decorators, that's fine. Maybe we'll get to list comprehensions. Maybe we'll let Reedham tackle that on Friday with me. And if we have time, we'll get to closures. But I really am just going to go section by section and see how you guys feel about each section. If it's something you really feel comfortable with, we'll move on to the next one and then focus on the one that you guys are struggling with. All right. So big picture, right? These aren't just fun, fancy tricks. Like I said, they're patterns. You're going to hear this a lot. Design patterns, framework patterns. You're going to see them. Oh, it says right there. You'll see everywhere in real frameworks. So if you ever wondered how Flash app.root works, which you might not have seen Flash yet, but you will very soon, or how Dash handles callbacks, that's decorators. So it's the clean one line data transformations, that's the comprehensions for the list comprehension. So it's taking all of that data and bringing it into one line, making it easier for you. And then if you need to keep the state without a global variable, that's a closure. And so that kind of brings you into keeping your application secure, because you don't want all these open ends to your program where bits and pieces of something could get in there, and then you got to go in and clean all of that out. And then I will also be posting this little cheat sheet in the Slack for y'all. Let's see, 1, 2, 3, 4. Now that I got the attendance in, continue from there. So let me just pull this up so maybe you guys can follow along. You should be able to just pop it into a web browser. It's just a self-contained HTML page. So let's see here. Just drop it in the thread video. Yep, there we are. Yep, there you go. All right, so got a little trophy in my way for some reason. So what we do to earn that trophy. All right, object-oriented programming, right? So object-oriented programming is really fun because it lets you design data types with behaviors. Like we learned last week, you can have the tank and you can have enemy tanks, you can have the user tank, you can have the co-player tank, maybe an NPC, but they're all that same tank object. So we use classes to encapsulate state methods, apply inheritance for specialization, like the inheritance of enemy tanks. Maybe they have that AI behavior that we set up with the random movements. And prefer composition to build complex objects from simple parts. So, using the role-playing analogy, we're going to make a class. Player, there can be many players, but every player is going to have the same name and level, maybe starting at level 1. They're all going to have a power, which is going to be level times 3. And then it's going to return a little F string here that says name, self, player, level, blah, blah, blah. So we're going to assign a player to the variable P. Ada is going to be level 5. So, oh, it runs. Nice. So, it's a good little surprise for myself. I thought I was going to have a broken out app here. So, as you can see, level 5. So, self level times 3 gives her a power of 15. Pretty simple. So now this is where we're going to get it into the inheritance and versus composition, right? So as you can see, we have the original character class, but we want to make a mage for the role-playing game. So we're going to take a class that's going to inherit from its parent class character. Everybody following? So it'll inherit everything, down here in the super, you're going to have the name and the level. So whatever's in the original class is going to inherit. So we're going to initialize it with its name and level, but we're going to add mana because this is the new attribute for the mage. So with the mana at 100, and we're going to give it an action where it can cast a spell. And you can see we're going to do the same thing with the inventory. Then we're going to make a hero. Hero also can have inventory. So what this is doing is it's letting us take these pre-made classes and objects and making them kind of interchangeable, like the Lego blocks, like I was telling you guys about a couple of weeks ago. So now we have all our blocks. So we can look at the map, which in this case would be the terminal, and we can take our blocks and we can put a mage here. We can put a hero here. We can put a couple of treasure boxes over here. We're starting to get the shape of something, right? What we see right here, mage, Turing, level 4. mana. So when he casts his fireball, you see the fireball is in here with the level and the mana, right? Of
Can I ask a question? I
course.
see that to um, hero and mage belong to character as children.
Mhm.
What about inventory? It's completely different, right? It's a different class. It doesn't belong to the character. It's separate.
Correct. You
Okay,
are
okay,
correct.
that's one.
Yeah, so the inventory is a separate class that is being added in, appended basically
Got it.
into the hero
Hero.
character.
I see.
So the hero is taking from inventory and from character.
Right. Yes.
Make sense?
Yes.
Great. All right, so now I'm going to do some imports. So this is where you see your first decorator, right? You got it, the decorator data class. So this is where we're going to be able to make a bunch of different items. The items are going to have keys. You're going to have a name, which is a string, price, which is a float. So the first item, which we call with the capital, because it's a class, it's going to be a potion for $9.99, right? Now, the way that this comes together, we'll see down here. So we're going to create a weapon class, right? So we've got our class called a weapon. Give it, oops. So in the weapon, gotta get your indentation right, which is, you don't tab it, it's 4. And then get rid of self and then. Right? And you guys will be able to download this and try this out yourself. So down in here, this is where you're going to add a different code, right? So your code goes here. And then for now, make sure it doesn't break. And give it a little pass, right? So, play around with this. You can't break it. And then let me know if you get stuck on any of that. We covered classes quite a bit last week, so this is more of just a refresher for you guys because I know decorators is what you guys really want to get to. So let's
So
get
the
into it.
weapon is gonna be child class to the item, right?
You're correct. Absolutely correct. Yep. So if you look up here in the item, you see that you'll have a name, right? The name will be a string. So in this case, we'll put, I don't know, sword, right? And then, look, don't like to hit tab and that thing does it. All right, we'll give it a price. And, well, maybe a float. So we'll say, oh, 90. All right. Also, we'll have to write in here for the damage. So the damage is something you're going to play with up here. So like we had with like the fireball, yeah, power, attacks with power. So I put it
So the role of data class is just basically a shortcut for writing the whole class instead of writing the init, whatever. You just write data class, and then the class will be created for you. So the
right,
role of the data class is just a shortcut for class, right?
pretty much. Yeah, because you know you're going to make lots of items, and so every item is going to have these parameters. So in here you have this item, right? And so instead of having to do this in the weapon, you could do, if you wanted to do it as an item, you would do, I don't know, W1 equals item, and then you could put sword and make it 1299, right? So that would give you the item to begin with. And then if you wanted to add on to it with the damage, it would just add into it with your um inheritance up here in your composition.
Right, yes.
Any other questions, y'all? So I know Anna's dying to ask questions about decorator, so let's move on. All right, so this is where we're going to see that whole data class and decorators in action. This make a little more sense here. So decorators wrap functions to add behavior. And they look a lot like, I know you guys did a little bit of CSS, so I know keyframes, media queries, things like that you were doing in your CSS that would add attributes to your CSS styling. It's similar to that. So if it looks kind of familiar to you in that kind of way, that you're kind of on the right track. It's adding to that function, right? So we're going to wrap the functions to add behavior and use them for logging, timing, access control, caching, all without changing the original functions code. So for a good example is like we have the log right here, right? So when it wraps the log, it's going to have your argument and your keyword argument. It's going to print the log calling the function name, right? And then it's going to return function with the argument and the keyword arguments. And the important part is remember to return it with a wrapper. So what that does is now that we have log here wrapping this function greet name, when we print hello name, it's going to also log, right? And so every time it calls log, if we had a timestamp in here or a counter or even both, like this many times was logged in at this timestamp, you would be able to attach this to like say a login for a company login or a time clock or something. And so every time Ada logged in, because of this function decorator, you would have this specific log that you could go back and you would tell it to export to a CSV that you dumps for you or sends it somewhere where you can grab that log and review it. And so you can change your function greet for different people. Say you have one for guests, one for admins, one for employees, one for visitors. Depending on what wrapper you have on it, it could log different. Like say you had log V and log V sends it to a different file, and then log A for admin sends it to a different file. And that's how you would be able to use the same greet function and have it log and send to many different places. Does that make sense to everyone?
A question on add wraps on the set that def log and then the next line.
Mhm.
What is this? I
So
usually been
wraps,
seeing.
yeah. So as you can see from function tools, we're importing wraps. So we're
Got
calling
it.
the wraps from the import. So this has its own little set of stuff. So let me open up a terminal here, right? And I would have to fix my screen share so you see what I'm doing. There we go. Yeah, so we'll open up a new terminal, right? In test.py, we're going to bring our imports in. So let's see what we got going on. Back to the decorators, right? So, um, option tools, we're going to import wraps, right? So in here we can see quite a bit of stuff, right? We're going to take a look at this and kind of break it down. So we have import wraps, import time, right? So wraps, like you were asking about, see if it'll give me the definition here. First, everyone made it, right? There we go. All right, so wraps. This is a decorator factory, right? So this is what I was telling you guys about patterns. So this is what's called a factory pattern. So every time wraps is called, it is going to create this instance. And so it's going to apply the update wrapper to a wrapper function, which we have over here at wraps with the parameters of function. So it's going to return a decorator that invokes update wrapper with the decorator function as the wrapper argument, and the arguments to wraps as the remaining arguments. So default arguments are as for update wrapper. So then it sums up with saying that this is a convenience function to simplify applying partial to update wrapper. I know that's probably a mouthful, so I'm going to kind of break it down for you guys a little bit and show you what's going on here, right? So let's just run, see if it'll run for us. Of course it won't, because we don't really have anything in there. All right, so the at wraps, right? We have our function just like we have over here in our decorators. In fact, this is almost verbatim. So this is a little bit more verbose. This might help a little bit. So we have our start time, we have our result, we have our end time. And so we're printing the execution of function name, end time minus start time, seconds, right? So it's going to basically run through whatever we attach this to, this timer function, and it's going to measure the timer, how long it goes, and then return how long that this function executed for. Does that make sense to everybody walking through that? You can always put something in the chat, and I know you're having trouble with your mic. Okay. All right. So, yeah, I mean, it can look like a lot right now, I'm sure, but the more you look at it, the more it's going to just make sense
So before a dev wrapper, we it is it's optional to put add wraps, or it's a requirement to put add wraps. It's not that I guess it's not optional because I don't see it here.
Yeah.
So it's similar to wrapper. Wraps and wrapper are the kind of same family.
Well, so the definition wrapper, this is the one that we are writing. So this is our function. At wraps is pulling from that import. And so what it's doing is it's running partial on this function. So we have a log function. And it's going to wrap another function. So we're going to run our wrappers. It's going to have our arguments and our keyword arguments. And then we're going to return the log, which is calling the function. And then down here, see, we got our arguments or keyword arguments. So when we run it, oh, it keeps doing it, but it's fine. Yeah, so the
Okay,
wrapper,
understood. Yeah,
you
understood.
did,
It's like
yeah,
function inside the function inside the function, basically.
yeah,
Um,
that's
do you
called
have to?
nesting.
Oh, I see, I see.
Mhm.
Do you have to always put this args and quarks, keyword arguments, as an argument to wrapper, or it's optional?
Well, it depends on what you're doing. If you don't have a defined parameter in your function, then these are defaults. You know, you have there's going to be an argument, and there's going to be a keyword argument. They don't know what it's going to be, but it's telling the function that I'm going to give you these two things. I don't know what they are yet, but I promise you they're coming. And so the because Python is very line by line by line with its threading. And so rather than getting snagged on this line and just sitting here waiting for whatever this is going to be or whatever this is going to be, it's going to say, all right, I trust you. You say there's something coming. Let's see what the next line says. And in the next line, that's where we give them the log and the function name. And so the log goes in here, keyword or the function name goes in here, and then it's going to return log and the function name.
Also, when we put arguments in that wrapper, that will definitely affect inside what's gonna happen, like in the print.
Right. So if we took this out, right, let's take a look here. I guess we'll have to do it in the terminal. Hardwired HCL. Yeah, so let's see what happens, right? Say we just have arguments, so we take the quarks out, right? And then let's take the quarks out of here. And then now that we got a return wrapper, it's outside the function, Michigan. Now, say we take, let's do one, we have to write another function first. So, one, two, fine. Sure. Let's just do that. At here, and print. Oops. Just make sure we got syntax going on here. Yeah. All right, so now that we have, and here you can see in action your question from earlier, Mia. So I'm using these different API configurations, and it's showing you the reasoning and the tasks.
Oh, I see. Yeah, yeah. It's your helper.
Mhm. This is an open source one, so you can go in and take, different ones, right? So there we go. Now that we got that going on. So, and again, from typing, you might not need this, so don't worry about that. So we're going to do the decorator. Got the arguments. So here's our example, right? We're going to do the definition of a slow function. And then him out of the way so we can see what's going on here. So, let's see what we got. And then valid syntax. Line one. Oh, this is why AI tools will never replace a human being.
I mean, we spend a lot of time troubleshooting anyway at work. With in
Yeah.
IT is like 90% just troubleshooting.
Mm-hmm. File execute in line one module. So it's a module that's calling it's getting a problem. There we go. So now we got it going. All right, so we wrapped the timer, right? And the question was like, what happens if we don't put anything in here? So let's leave a wrapper blank. Then we have functions not defined, right? Let's see. All right. Now we're back to the angry can't complete. But say you want to put your own parameter in, right? You could change this out as long as you remember to define it in both spots. It doesn't have to be args and quargs. That's just a standard naming for the placeholders to make it easier for you to get in the habit of this is what's going on. And then this connects down here in the result function. Makes sense?
Yes, yes. So it basically changes what's inside and then spits out the result that was changed.
Right. So if we read this out longhand, right? Uh, this definition function wrapper is going to take an argument. And in this one, I've set the parameters of any. You can change this. You say, I'm only going to give you integers, you know? And this is kind of a catch-all where if the function tries to run with something that isn't an integer, it's going to throw a type error, so that's later when you're doing your data validation, you can set what kind of data is being put into this function. Right now, we're not worried about it, so we have it set as any. So it's going to take one argument, and one keyword argument. And so in there, we can see here is our function. Here is our variable for the execution time being returned. The counter. And so in here, it's going to try. This is your try try and accept block to have graceful error handling, right? So in this function, it's going to try, and if result equals function or argument and a keyword argument. So if it meets these parameters up here, it's going to return the result. Finally, we're going to have our end time minus the start time is going to equal the execution time. And then this down here is a formatting thing. So this is how many decimal places. So as you can maybe shake it, actually. Anyway. So that's what happens when you start messing with keyword arguments. All right, so does everybody understand what the wrap did? So we'll go on to timing, which is kind of what we were just messing with over there. So we have a definition of time it, which is why we're going to import the time, because we're going to start using these time methods in here. So we're going to have our start, we're going to have our result, we're going to have our end. Once again, we're doing our wrapper with the arguments, the keyword arguments. So we're going to print the time, the function name, and then the result, which is the end start. Then we're going to return it. It's going to return the result, and then it's going to return the wrapper. So we add time it to the definition compute and see how long it takes to return 42. So pretty fast. Which is basically a less convoluted version of what we had going on over here. So let's get rid of that type variable because I'm pretty sure that's probably what's messing it up. So in here, let's say instead of just returning 42, let's give it a couple of parameters, right? And give it A, B. Not going to worry about the any. And then return A times, oops, A times B, then, oh, it's too fancy. Well, exponent by 3, right? Just get some kind of fun number out of it. And then we'll compute with the parameters 2 and 3, all right? And yeah, what is so let's speak here. What time? Time function. Oh, yeah, now I'll do it. Just so you know, anytime you're live coding in front of a class, something is always gonna break, so just be willing to look like a dummy sometimes. It's gonna be all right. There's no judgment. So, you see the time to compute took 54 instead of 42 before, right? Or, I mean, the result is 54. Again, it took 0.00 seconds, which is on a small function like this is very, very fast. So back to this. So that's what the timer wrapper was doing. So the timer wrapper is running all of this when we call the compute function. All right, so a parameterized decorator. This is where we're going to get a little bit more complicated. And so we're going to start with required role. We're going to nest the decorator function in that. We're going to nest the wrapper. The wrapper is going to do this. It's going to return the wrapper. It's going to return the decorator. And then we're going to have the entire parameterized decorator, which is required role, right? So anytime we do required role, it's going to take this parameter, which in this case is admin, and it's going to run this function, run this function. So we have the user authorization role only. So if role and user gets roles, it's going to list these roles, return that, right? Otherwise, it's going to give a forbidden. So in here, you see admin running the function. As long as it's an admin, it's going to print access granted. So instead of having to do all of this for power user, admin, MIT person, you can set roles and assign these roles to the different keywords. And then as you get or lose people that are assigned to these roles, when they run this, it's going to say, what is my hand up? All right, Zoom. Zoom just likes messing with me, I think. Um, anyway,
Actually, this code made sense now, everything. This was to understand easy. It was easy to understand since admin. Now I got it.
right. Yeah, sometimes
Yeah,
it's
so
just
basically to call and pass the function, if you give the right configuration as the wrapper wanted, it will give you right result.
exactly. Yeah, so once this evaluates to true, it knows that this is okay to go. And then once this evaluates out to true, it knows this is okay to go. Because everything we do is sequential, right? So in the code, this is going to be stored ahead of time. So whenever it gets to this, it's going to make sure that it knows that it all refers to this. And so all of this is compartmentalized into this for you so that maybe 1,000 lines later, you are going to start using the required role because that's where you're going to start giving all the accesses and permissions to whatever it is, maybe a database that you're working on or something. And so instead of having to go all the way back up there and do this for every role, you can just call that decorator and bring it in here, and it's going to make your code more readable and easier for you to go back and be like, oh, that's what I was doing. Makes sense? It works. That's awesome. Let's see. All right, got about 10 more minutes. Let's see here. More complete. I could draw a little stars here. All right, list comprehension, right? This is where this is probably one of the most important things because data is the core of like everything you're going to be working with. So list comprehensions express transformations and filtering in a single readable expression. You can use them for lists, sets, dictionaries, and generator expressions. So we have in here squares. So we have our list, nums, right? 0 through 4 in our list. So squares is going to take n times n, and it's going to iterate for every n in nums. So 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So on and so forth. So using this list comprehension in here, we're taking a list inside of it and we're doing something to it. So that way, all you got to do is print squares. And then you get whatever that list is already squared for you. And you can do this with dictionaries and sets. So as you can see right here, it's going to do the same thing. So we're mapping, we're doing links. So here we're going to print the mapping, here we're going to print the links. So inside the list comprehension, it's still using pairs, right? There you go. Brings it back. There's your pairs. And with generators, it's going to be like this. So n for n in range. So range sets your limit, right? And then here, this is how we're going to make sure we have even. So n modular. Have you guys seen modular before?
Yes.
Okay. So because of modular 2, if there's no remainder, we're automatically going to know that it's an even number. So it will print the next, which is next evens. So in here, it can go and run and it will literally go in and just grab all your even numbers. Here's a little try it for you guys. Let's see if we got time to cover closures a little bit.
Is that the KV is like for key value or just for the pairs?
So that's shorthand, and yeah, you're right. So basically, key value for key value in pairs. So semantically naming it like that is how you were able to identify, you know, what that meant.
So here A would be K and one would be V or no?
Right. Correct.
I
Yep.
see.
That,
Got it.
yep. You're
And then
exactly right.
where's the W came from? Length of W.
Oh, so
Which one?
lengths for W would be word, right? So this word, that
Oh, got
word,
it. I see. I see.
that word. And so this is a good example for maybe being a little more semantic in your naming. So this is an old practice of just using because when you're writing lots of code, you want to keep it succinct. But if you make it too short, then like you just noticed, you're like, well, what is the W for? So 3 more characters in your code to say length words for words in this list of words will make it more readable for you. And so I would encourage you to put the extra typing in a little bit. Not only will it help you become a faster typer, but it will help you understand your code because then you'll be able to go in. And so I've seen this enough that I know that, yeah, that's key and that's value. But when I was first starting, like you were, like I could have been hung up on that for a while. Why 1, 2, 3 for links? Okay. So in the links, that's a good question. Why is it 1, 2, 3? Length for W, length for W in. Um, because that's not the index. That's a good question. Let's find out. Let's go a little helper together. Explain why one, two, three. Hmm. Brain. Okay, so what it's saying is because we're doing a set, right? The comprehension builds a set of 365. So it's going to store those unique values. Ask me questions and just explain this to the. Now you're just gonna ask me a bunch of questions. Unordered. Print it as one, two, three. You try example 3, 5, 6, and any other order. Key point, fairly based comprehension can includes a set of unique links, not a list. As such, do not. Oh, that's why, because it's not preserving the order in their printed form. So instead of returning the actual length, which is 3, 5, and 6, it's going to print out the first one, the second one, the third one, because each one of them are unique. So if we had another 3-letter word or another 5-letter word, it wouldn't count them because they wouldn't be part of the set. And so the reason why it's doing this in the sets is it's telling you you have one of these, one of these, and one of these. It's not actually defining the length of the word when it breaks it down. So I can see why that's confusing because that kind of confused me a little bit too. So for that, we both learned something there. Does that make sense, Elena, or should we look into it a little longer?
Yes, makes sense.
Yeah. Okay. All right. Good question. I like when I don't always know the answer, so that I can show you guys how we look for the answer. So we're almost at time. Um, the next section is going to be on closures. Like I said, I will be with Reedham on Friday, so if you guys want to pick his brain as well, you're welcome to come in. I did put this cheat sheet in the chat, so you can go back over it, play with it, take a look at it, see if it helps you with what you're struggling with right now. And I see Vasily, I need to add you to my roll call. And other than that, if you guys have any questions, the rest of the time is yours.
Thank you very much.
Of course, man. You're welcome, Vasily. Elena. All right, with that, like I said, if you guys have any questions, just reach out to me. If not, I'll see you all on Friday.